We're streaming now, so I don't know if you guys need to share a link or something, but it should probably be the same one.
Yeah.
It should be the same YouTube channel each time. Yeah, I didn't get an email about it, so I figured somebody had come. I'm going to switch this back on, by the way.
Okay. Thank you, Brian.
Yep.
You're welcome. I did a lot.
Brian, yes. Yeah, Brian.
Hang around and see if we need to like audio.
So bear with us on the technology today. We did do a test run, so it should be all good. We're going to have a little Q&A we'll leave you during the actual presentation, but then at the end, we'll just do a few questions. There are some metal samples that sit on some of the tables. I think there's 6 of them. If you just want to kind of pass those around so people can see, feel, and touch a little bit. We've got some general AIA announcements. We have component meeting today. The YAP construction tour actually will probably be in September. We're looking at touring. Architects is working on the new Kuat facility, if I'm saying that right. Yes, Kuat, right? And then the end of the month, as some of you know, we have construction going on. I don't know if, Karen, do you want to say a little bit about our thoughts on that? We have 3 teams participating. We'd like to get more involvement without so much work on your end.
Right. So yes, we have 3 firms that have agreed to sponsor teams. We are looking for more firms to, because we ideally like to have like 6 or 7 teams at least. But we realize everyone's really busy, and so it's not a great time to do this kind of work. But if you are interested, it's possible that your firm could sponsor a team, be in a different kind of category than the other ones. But for $250 or $500 or even different levels like that, what we're doing is we really want AIA Springfield and HSA to just kind of come together and have a time where we can gather a lot of cans, raise some money, get the cans, make some designs, and just kind of have a celebration of what architects can do for Ozarks Food Harvest and do a design project in the meantime with our students.
Right. So if you don't have the time, as many of you don't, to actually go through design, working, and all this, you can just sponsor, and we put your name on that, and basically what she's saying is the students, we're getting them involved and matched up, and they would take the lead on designing. It might be like, they won't be able to coordinate things, they might wrap it in construction paper or something to make the design, but they'll have that week to design it and then they'll build it. But the funding is the hard part for the students. So if you feel like you still want to be involved and want to do that, we'll be sending out an email about that shortly.
Yeah, or contact either or me, like this week as soon as you can. It'd be great if we could get at least 7 teams.
Again, no pressure, but if it was time and logistics that were holding you back, feel free to let us know. We'd love to get you involved just the same. Let's see what else we have. Yeah, September, we of course have our component meeting next month. It's going to be landscape forums, if some of you are familiar with them. They're going to come and talk. And then there's that tentative construction tour. Also, some of you know about the Big Brothers Big Sisters Bowl for Kids' Sake event going on. It's also posted on our AIA Facebook page, I believe, if you want to find out more information about that. And then the AIA Mo Award Banquet annual meeting will be October 4th. Thank you to our sponsors. Danielle, Interpress.
Oh, yeah.
Gosh.
So, you're going to forget me again?
No, I'm going to go. And Terracon.
Oh, okay.
Yeah. Next meeting,
No.
landscape forums, construction. That's a little, oh, she's already established our, you can sponsor us with tuna cans, sponsor at $250, Bush's Beans at $500, or the Andy Warhol level of it. Oh, and this is, Doug gets more recognition. Jennifer, do you want to chime in on that a little bit?
Well, Doug is just being honored by the AIA Missouri for his distinguished service. So anybody that is going to attend the AIA meeting in October 4th and 5th, it'd be good to have good support for our chapter there. It's quite an honor. Yep.
And then the 2019 Slate of Officers will be elected at the October business meeting. This will tie into what Dan's about to talk about too, a little bit with the Sustainable Operations Committee. And then we will be nominating several awards this year with the salute to design construction. See the categories below. So if you have candidates that you have in mind, please let us know. That's it. Dan, do you want to say a little bit about the sustainable operations?
No, I'm good.
You're good?
Just kidding. Good afternoon. I'm Dan Scott, for some unfamiliar faces in the room. I am chairing the Sustainable Operations Committee, also accompanied by Kate, Bruce, Lane, I don't see Lane, Andrew Wells, Andrew,
Stephen.
and Stephen. There's Stephen. And we're spoon feeding you little bits of information every month in the way of an announcement from me for the goal of when we get to October, you're going to be so tired of hearing from me that you're going to support what we're trying to accomplish with that component. We have begun to set up structure of a permanent foundation for our component. We have, as I reported last month, we have board approval to set up a permanent fund with the Community Foundation of the Ozarks in the amount of $55,000, but that is going to be subject to the approval of the membership in October at the business meeting. Because once this money is let loose out of our hands, we don't get anything back but the earnings. It is permanently in the hands of the Community Foundation at that point. So it is a big decision. Next week and a half or so, we're meeting again. Our next step as a committee is to get through a little bit of procedural items of who's the signatories, how we interface with the board as an independent committee or not an independent committee, and most importantly for you all, as far as input back to us, is we get to name this fund. And if you have ideas for that, we want to hear from you. Because when we get to October, we're going to present this whole package to you, and we will have it named at that point, and we'll ask you to pass it as a complete package based on the advice of the board. We are going to keep the name generalized, so it doesn't sound like it's just a club fund. That's just us, but it's something that, a frustrated architect who happens to be a banker or a college president or something can also feel comfortable contributing to, because it is a fund that will be able to receive tax-deductible donations. So we want to be a little bit broader focused in its name. So if you have ideas, please get those back to me or anyone on our committee. And next month, I'll apologize in advance, I'm considering making an extended announcement to kind of go through the entire process of the announcements that I've made the last 3 months before this. So we lay out the entire path, so when we get to October, we'll be able to kind of make a motion and move forward if that's the wishes of the membership. Any questions? All right, thank you.
Thank you, Dan. All right, we'll get Eric on the line. Eric, can you hear us?
I can.
Okay, I'm going to mute us for now, and you can take the stage.
Okay. I'm not sure that once we get to the questions portion of this, I'm not sure that I'm going to be able to hear very well, judging by the announcements that were just made, but maybe we can figure out a way to get those closer to the microphone.
I might MC that part if we have to.
Oh, okay, great.
Okay,
cool.
Thank you, Eric.
All right. Okay, well, my name is Eric Steele. I work for Zahner in Kansas City. We're a custom metal fabricator. I do recognize that I work for a custom metal fabricator. My last name is Steele. I've never come up with a good response when people point that out, but it works for me. People don't forget my last name. So my intentions here is to kind of take you through some projects that we've worked on while discussing the different materials that we use. Kate mentioned we have some samples that I sent that are there. I'll talk about those samples a little bit and the methods that we use to arrive at those finishes. I'll also talk about our various approaches to bringing work into Zaner, and our customization capabilities for producing the work, and then how we arrive at engineered solutions for a final product. So these are the samples that are there. There is, and what I've got listed here on the screen is some of the materials that we commonly use. There are other materials that we use, but these are the most common materials. So of the samples that you have there, 2 of those samples are zinc. And as you can see, you're getting very different appearances with those samples. And so what we're doing is we're applying solutions to the surface to get different color tones and variations in the surface. So we do a lot of patina work. Some of them we've gone out to market with, such as the ones that you see here, are ones that we have a standard process for producing these patinas. And then there's a couple of projects that I put in here that are actual custom patinas that were specific to that project. So you've got the Hunter, what we call the Hunter patina on zinc, which is what you're seeing is the gray material is the base material. That's how it comes to us in sheet form. And then we apply a solution to get this kind of white variation on the surface. And all we're doing really is just speeding up the oxidation process to gain those variations. And then the next sample is what we call our Roanoke patina. And so as you can see, they're very different in color. This is more of a white variance on the surface, and then this is more of an earth tone. And I recognize that the image here doesn't really represent the sample that is there, but these are the actual samples that are there in your room. So the Roanoke patina gives you more of the earth tone, just a different process to gain that aesthetic. And then I've got our dirty penny copper, which is, again, it's just taking the sheet form of copper and applying a solution to speed up the oxidation process, but also give it some variation. So if you use something like this copper sample, you get the variation from day one when it's applied to the building or to your artwork or whatever the application is. And then over time, it's going to continue to oxidize. So, what you're seeing here is like, the copper comes to us like you would see a bright, shiny new penny. It's the very bright copper tone. And over time, of course, it oxidizes and can go to the browns and eventually to a green if it's in the right environment. So what we're doing is we're applying a solution to the surface to give it variation from the beginning. And so when it begins to oxidize in the environment that it's put into, it oxidizes it at different stages. So, where you're seeing the browns, that's going to oxidize at a different pace than the bright orange areas that you're seeing. So that variation remains through the life of the copper. And then the dark one here, which obviously the picture's kind of taking away the color from it, is what we call our Solanum sample. That's taking architectural weathering steel, which is also commonly known as Corten. And we apply, again, a solution to speed up the oxidation process to bring out that rust color. And what that rust is doing, so what architectural weathering steel is it's copper-bearing steel. So there's copper that's infused into the material to prevent it from actually deteriorating. So if you had just regular steel and you apply a solution, you get the rust, it will eventually rust through. Whereas architectural weathering steel, which you see on a lot of bridges, it's a very strong material. It won't actually deteriorate as it's rusting. The rust is actually forming a layer on the surface that protects it. And then you're seeing our perforated stainless steel sample. So this is a custom perforation in what we call our angel hair stainless steel. So the previous four are all patinas, where we're applying solutions to speed up the oxidation process, whereas the stainless steel, we're applying an abrasion to the surface that's a mechanical finish. So imagine a brushed finish like a number 4 finish that's common. We're applying a finish on this one in particular. This angel hair finish is a brushed finish, but it's a non-directional brushed finish. So it's kind of the brush is being applied in a circular motion. We have other patinas. We have a copper variation of our patina where it's actually going to the green state. We've done several projects utilizing that material. We have different mechanical finishes that we can apply to stainless steel. These just happen to be the ones that we had available that we could send for this presentation. So this project is a project in Chattanooga, Tennessee. It's called the Hunter Museum. This is with Randall Stout Architects. And this is utilizing the Hunter patina. So this was the project where we came up with that patina process. So that's why it's called the Hunter patina, because this is the Hunter Museum. So what you're seeing here is all zinc material with that patina applied to the surface. The unique thing about this project was they wanted it to be stone, the entire building, and they were running into a lot of budget issues. And so they came to us and were asking us, what we could supply that gives kind of a stone-like appearance. And so we came up with this Hunter patina that gave it a stone-like appearance. But what we found out throughout the process was that making this a zinc panel system also saved them money on the structure. So they weren't trying to hold up all of that stone material for the structure. So going from a stone material to a zinc sheet metal with the patina applied to the surface was a solution not only for the material but also for the structural steel to bring that cost. And that's another image you can see better of the variation in the zinc material. This is another Randall Stout project where we used the same zinc material but have the Roanoke patina. So this project is in Roanoke, Virginia. It's called the Taubman Museum. And so it's another project where we utilize zinc and put a custom patina to it. It was something that we found to be stable and something that was easily applied to materials to control the process. And so this is another patina that we came up with during this project and ended up going out to market. We've had several projects now that we've used this patina. And then you're seeing the angel hair surface on the stainless steel surface here. Another image of the Roanoke material. This was, so the original, the first picture is when the project was newer. This is after it's aged a little bit. So this is a more recent picture where you can see that the zinc has oxidized a little bit more, so you're getting some more variation. It's changing, which is part of having a custom patina on the project. That's something that we try to communicate as best we can up front whenever an architecture firm comes to us wanting some sort of a custom patina on the material. Part of buying a custom patina is that it's going to have variation. So you can see here you're getting a lot of color variation from one panel to the next. If we're not clear about that up front, if we don't have a lot of discussions about what the expectations are up front, we can get these panels out on the building and all of a sudden we're having conversations about why this panel doesn't look like this panel or vice versa. And that's something that, as I said, it has to be an expectation that's set up front that you're going to get variation, and that variation is going to change even after it's submitted to the atmospheric conditions where we apply the material. So this is Roanoke, Virginia. It's going to be a very different environment than if the material was in Missouri. and we can't control that. And so, you know, we have a lot of those discussions. It's something that we talk about with our clients a lot. That our patinas are not a paint, and that's part of why you go to a custom patina. So this is a project in Richmond. It's the Children's Hospital of Richmond, and it's another project where we used zinc. And this is one where we came up with at least one of the color variations here was a custom application. So they wanted to get 4 different colors on the building. They wanted to use zinc. So you can see here, this is kind of the Roanoke finish with a perforation in it. And then we have what we call our Baroque finish, which is another patina that we found in the market that is a little bit darker than the Roanoke. And then we came up with this third one that was, well, actually there's 4 here. So this is the material that is just pre-weathered as we receive it. So there was no patina to this one. This one that you're seeing kind of the red tones come out of was a custom process particular to that job. And so what we did on this project was we had a design assist agreement up front where we would do a sample process. And this was, you know, we invite the architects and the design team to come into our facility and see our process, understand how we're applying the material, so that helps with the expectations down the line. So you're seeing, you know, the Rona finish, the Baroque finish, and then you're seeing this red one. And there's some variations here that I don't think were used. So this one was closest to us that has the red. I think we didn't end up using that. It was more of these back here. But you can see we went through a rather large sample process where we took several sheets that were pre-perforated, applied a process to it. We have to record everything that is occurring during that process so that we can repeat it later, such as, you know, the solution, the way that it's applied, the environment it's being applied to, the humidity and the temperature during the application, and then how long it took for it to cure. So this is all information that we have to collect as we're doing this. And then, you know, once we get to a stage of being able to review and choose what variation is most desirable, you know, then we go back to that data and reproduce it using that data. So this is another zinc project. This is one that is right here where I am now. This is our headquarters in Kansas City. And so this was the original physical mock-up that the architects produced. This portion here is our existing building that was built back in the early 80s. This is our fabrication facility. And then over here was where we were adding on. So this is more fabrication space here. And then this is kind of a crazy geometrically shaped office space. And so, you know, once we saw this clay model, we really liked the aesthetic of that. So we ended up using zinc on the surface of the building. And this is what you see from the street. So, you know, you're seeing the zinc, and we wanted some of the oil ganning in the surface to replicate that clay model that we were looking at there. Up on the top of each one of these pods is a skylight to let light in. Over here is a very large storefront where it's letting more light in and a window on the other end. So this, you're seeing a close-up of the zinc material. So we cut this out on our laser cutter in abstract shapes and used exposed fasteners to apply it to the surface. As you can see, and there's going to be a couple more projects that I'm going to show you where we have exposed fasteners on the surface. You can't see the exposed fastener from just a few steps away. To get up close, and of course you can see them, but these are just overlap shingles, very easy to apply. It gives the installer, the people that are installing it, some artistic flexibility in how they're going to apply it, which makes it go faster. And then here's what the interior is. So this is our engineering space. And now I'm going to move from zinc to aluminum. So what we're using here with the aluminum is, you can see this kind of thin application where we're putting some geometry in some waves in the surface of the aluminum structure that we use to produce this building. So back in here is that fabrication facility, and that has the structural steel to support everything there. And then we come off of that structure with these aluminum fins, and some of these come all the way down to the foundation. Some of them die into, you can see that there's this one area where we had to apply some steel, but everything else, the structure for this building was done out of aluminum. So the aluminum fins are moving this way for the roof structure, and then as you turn the corner at some point here, the aluminum fins are coming up at a different direction and are attaching into the side of these aluminum fins. So these are all 3/16 plate aluminum that are cut out on our water jet cutter. And then we have an extrusion that we apply to each side. So we're essentially making an I-beam out of aluminum. And then that is the structure for the roof. And like I said, due to the way that this was such an open space here, we had to include some steel. We did everything we could to eliminate as much steel as we could out of the project. But we did end up adding a few columns in there. So it's a nice space for our engineers to work in. It kind of opens up the doors of the imagination for what can be done, not only aesthetically but also structurally. And then this is our original fabrication facility. This is from 8th Street. Kind of the same idea. So both of these designs were by Crawford Architects here in town, here in Kansas City. Crawford and Zahner worked together to come up with some unique solutions for. This one was done several years back. We have this is our north dock, so you can see we have a rolling door that opens and closes. So this is our north dock and our larger fabrication facility, so that our trucks can back in, and then we have an overhead crane inside here that can pick up some of the larger units that we make and set them directly onto the truck, and then off it goes. In between the fins on this portion, we have a glazing system. So out here it's open air where the trucks pull in, but there's a large garage door that shuts here, and this area here is a conditioned space. So there's glass panels that are in between the fins on this portion of the side here. And I'll revisit the east side on this after a while. Maintaining the aluminum discussion. So this is a project at the University of Kansas in Lawrence. It's called the Rules of Basketball. So an alumni from KU had purchased Naismith's actual physical copies of the rules of basketball that were originally written, and they wanted to make kind of the shrine that artifact could be placed in. And so what they've done here is they've made a pedestrian bridge that goes from the parking garage to give access into the Allen Fieldhouse. And what we did here on this facade was we cut in some of the letters to produce the words, some of the words that were in the rules of basketball for this facade. And then on the inside, you're seeing some imagery that we came up with, and some of the text that's on aluminum for further information about those rules. So this is an image of Bog Allen. And then as you get closer, you can see that we used the depth of the cut for the letters to produce the image. So as you back up, you can see that the darker the letters are, gives you those gray areas to produce the image, which is a similar, I'll get into some of our perforation methods to achieve imagery as well here in a little bit. Again, some more aluminum projects. So I wanted to kind of give you some that were, you know, more typical aluminum applications, and then this is more of buying large plate and then cutting abstract designs out of it. So what you're seeing here is Jan Hendrik's design in Education City in Doha, Qatar. And so Jan Hendricks is the artist on this project. He came up with the design and the layout of what we were cutting. We came up with the methods of bringing in these large half-inch aluminum plates to set on our water jet cutter. Our water jet cutter has a 10-foot by 20-foot bed, and so we would actually bring in aluminum plates that were 10-foot by 20-foot, put them on the water jet cutter, and cut out these unique patterns. And so, you know, as you can see here, you can kind of see the joint line here for one 10-foot by 20-foot panel, and then as it falls across that joint, the pattern is continuing. So this is all laid out in a way that each panel meets up with the next one in the artist layout. So these panels were cut here. We had a panel or a hardware application on the back side for support, and then we would send them out for painting. These were all painted white. And then we sent them in a container to Doha for one of our partners in the Middle East to install. And this is the final product. So now moving into copper. So as I mentioned before, we have a lot of copper patinas that we'll work with. This is a project, this is the De Young Museum by Herzog and Demeron in San Francisco. This actually had, I think, 7,000 unique panels on it. All of them are either perforated or embossed with a bump type of embossment. So imagine a perforating machine that instead of perforating all the way through the material, it just applies an embossment that's a similar size to the perforations. That was utilized on this project to come up with a way to give the aesthetic that the architect wanted for the facade. And this was all done with natural copper. And so when we installed this, it was the bright, shiny new copper. And then over the years, it has gone to the brown. And we're starting to see some of the green tones starting to creep in. And this is in San Francisco where you have the saltwater fog roll in every morning. This is in Gateway Park in San Francisco. And so it's actually, I think it's exactly 1 mile from the coastline. So that fog rolls into San Francisco every morning with salt water on it. And this has been done since 2005. So over 13 years, we're just now starting to see some green pop up in that condition. One of the great stories about this project is we were under design assist on this project, and one of the benefits to using us for design assist is that we can watch the metals market while we're under contract and kind of give our opinion on when you should buy material. On this particular project, with it being copper and for being such a large project, we were under contract, we were placed under contract for the material. And then all of a sudden the bottom dropped out of copper. And so all of a sudden we had a surplus. And so we went, instead of pocketing the money, we went back to the ownership group and said, listen, you know, we're going to buy this copper, and it's a lot, you know, the prices dropped considerably. So, you know, we gave the money back to the ownership, and with the understanding that they would add some more scope to the project. So in lieu of us doing just the vertical facade that you see from the ground level, because we were able to get that money back, they ended up adding the copper roof to the building as well. So the entire building envelope of this museum is clad in copper. And here I'm showing you kind of the different stages of copper. So, you know, when it was installed, it was the bright, shiny new copper. You can see the perforations and the bumps in the surface here. And then you're seeing as it gets to that, you know, recognizable copper tone as it oxidizes. And then this is more recent where you're seeing it, where it's gone to the full brown color, and you're starting to see in the joints some of that green starting to come out. And this is over 13 years, so what's nice about this is, you know, this is a museum, and, you know, over the years it's completely changing in appearance, which is something that the architect wanted. Now this is a project where we applied our patina process to the copper to get it to that green state. So we're oxidizing it to its fullest state to get to that green color. This is the Kansas City Star printing building in Kansas City for the newspaper here in Kansas City. So another one of the materials that I mentioned is copper and copper alloys. So, you know, copper, when I talk about copper alloys, I'm talking about bronzes, brass, and so that's just a variation of the chemical makeup of the copper itself. It's applying more or less to the material when it's being produced. So this is a project that we worked with. We were actually contracted by an artist that was awarded the project to build these entrance leaves as you're entering the building. So this is the Museum of the Bible in Washington, D.C., and the artist is Larry Kirkland. And what Larry came up with was he wanted to use the Gutenberg press as kind of the design of these two doors. So if you can imagine it, the Gutenberg press was the first machine that was invented to mass-produce books. And so, you know, the first mass-produced book, of course, was the Bible. And what Larry wanted to do was kind of use that Gutenberg press design to achieve this aesthetic for these entrance doors here. And so what we did was we did a lot of studying on letter boundaries and how the letter blocks were used in the printing presses. So you can see here what we're doing is we're taking these letters for the Latin characters, and we're simulating these letter blocks. Now we made these into, like, this is one panel here, this row that you're seeing right here is one panel. And then we're putting kind of these faux joints in between the letters. And we even got down to, so one of the things that was tough about printing presses back then is the spacing. So you can see, you know, we have some blocks that are just nothing, they're just meant to be there for space. But also we even got into, let me back up, some of the letters, and I'll show you one here in a little bit. Some of the letters like an L or a T or some of those that have horizontal portions to them, they mess with the spacing. And so they would have to do what's called a kern, where they, you know, on the actual letter pieces that they would put to the printing presses, they would hand file these pieces back. Let me show you what I'm talking about here. So see how this piece here is overlapping over that joint. So that's how detailed the artist wanted to be with this, was not only simulating the printing press, but to do it as close as possible to the actual printing press. And so, obviously they're scaled up for the size, but you can see here where this letter comes over, and that's how they actually made those blocks. They would cast these letters, and then they would use a file to file back this underneath of this portion of the letter so that it would overlap the next one, so that's basically worked correctly with the printer. So the methods that we used to achieve this was we bought 1-inch thick bronze plate, and Larry came up with the files that showed the text that he wanted. Of course, everything's backwards since it's a printing press. We took his files and converted it into our machine language. So this, what you're seeing here is the machine tooling paths that are going to occur when we put it into our bridge mill. We have software that lines out exactly where the path of the tooling is going to go while it's removing the material. So you're seeing here the bridge mill in action. It's basically just a router that's coming down and routing out the metal. As you can see here, it's leaving these machine marks as it's forming these metals and removing a lot of the bronze there. So you're seeing all of those. So these are the faux joints that we applied, and all of this material was removed to make these letters stand out. And then we applied a texture to the backside surface to get rid of those machine lines and make it look more like a cast product. And then we applied our angel hair actually to the surface of the letters to give it more of a polished look, like you would see on an actual printing press. And then we applied our patina. So this is a custom patina that we came up for this project, and we wanted it to be kind of sloppy. You're seeing, around the edges here, it built up a little bit more. You can see it's spilling over there. It's kind of sloppy, like the ink would have been on the printing. So here's the final product. So this is in Washington, D.C. It's a Museum of the Bible. And Larry Kirkland was the artist for this. So these door leaves, they're not actual operating doors. They're there for decoration only, but these are 40 feet tall, and I think this one was 16 feet wide, and this one's a little bit wider. That was a really interesting project. I was lucky enough to go to the letter foundry when we were doing research on these letters, and communicated with Larry throughout the project as far as what his expectations were for how those were going to be milled out and the patina appearance and all that. It was a really interesting project. I enjoyed that. So this is a project. This is an interesting one. This is in Jakarta, Indonesia. So this is the Australian embassy in Jakarta. This is by Denton Corker Marshall out of Australia, and so this is the office compound at the embassy. And like I've mentioned before, we have a lot of different patinas that we've gone to market with. And what it seems to me that they did on this project was they looked at what patinas that we've gone to market with and just said, yes, we'll have one of everything. And so you're seeing what we call our Solomon patina here on the pre-weathered steel, or on the weathering steel. Here you're seeing the green copper patina, similar to the Kansas City Star building. Here you're seeing the Hunter patina on zinc. This was a bronze material where we just kind of darkened it slightly, and then we went with clear anodized on another side. So that was an interesting project from the standpoint that we were producing a patina in the Midwest and then shipping it out in containers to be on the ocean for several weeks to arrive in Indonesia So when we first started looking at this, we demanded that they have some visual mock-ups because, and we were going to have to go through the whole process of applying the patina exactly how we wanted to apply it, package them the same way, ship them the same way, because we had to know that they were going to arrive in the state that was expected for the final product. So as you can imagine, those containers get humidity and moisture in them as they're being shipped overseas. And everything turned out fine. I mean, you can see very little variation in the weathering steel, which really surprised me. They wanted more variation in the green on this, and we were able to help them with that. So yeah, it was an interesting project. This is some more weathering steel. This is for a residence on Pender Island in British Columbia. And the interesting thing about this one is you talk about managing the expectations of the patina. So, you know, we sent out samples of our solanum, similar to the piece that you have there, and you know, it's much darker than what you're seeing here. So, you know, this is on an island in British Columbia where it gets lots of rain, lots of humidity, lots of salt in the air. When we first applied this, everything went orange. And there, you know, there's no way for us to know that other than sending something out there and setting it up as visual mock-up beforehand. But this was one of those where the product started going on the building and there was a timeout called and had to fill everybody up and figure out, you know, what, you know, kind of reestablish what the expectations are, because it wasn't the dark, rich color that you're seeing on the sample there. It went to a bright orange, and it has maintained that bright orange color, which is surprising to us. But you know, there's only so much you can do when it comes to an oxidizing product. And a lot of people ask, can you apply some sort of a coating or something that will freeze that color? And the answer is yes, we can. But all of those coatings that you apply eventually break down under UV exposure. And so we never recommend it, because when it does break down under UV exposure, it doesn't just disappear. It kind of cracks, the clear coating will crack and have these microscopic kind of webs that are in them, and it's not a pretty look. So we generally recommend these clear coatings that are going to be exposed to UV. And then this is back to the color like you're seeing there. So this is weathering steel. This is on the spaceport project in New Mexico. This is where Richard Branson with Virgin Galactic is going to fly people up into space. These are the hangar doors for the planes that are the jets that are flying up into space. So this was a Norman Foster project that, you know, they had an expectation for the weathering steel, and we met them. So it's the darker color. Now this is a much drier climate than the one that we were viewing before on Pender Island. So this worked out well. It's the darker, rich tones that were, you know, similar to what we had offered up front. So now I'm going to get into stainless steels. So this is what we call our angel hair finish, which is a brushed finish that's more it's non-directional. And then we have what we call our glass bead finish. So this is you're taking stainless steel and putting it through a machine where glass beads are forming a texture onto the surface. And really what it's doing is it's building the surface. So when stainless comes to us in sheet form, it's generally in what's called a 2B finish, which is very reflective. We take that material and we either apply the angel hair to the surface. Angel hair kind of gives it more light. You're going to see some sparkling in it. It's almost like a metallic color. And then with the glass bead surface, it's much more dull. It's much more of a matte finish. We did the first several Apple stores in New York, Los Angeles, and some of the major cities around the United States, and this was the material that was used for those projects. So if you've seen an Apple store, you've seen glass bead. This is a project in Eugene, Oregon. It's the Eugene Federal Courthouse. It's in Morphosis. Tom Main's group, Morphosis, was the lead design architect on this project. So this is angel hair stainless. This is a project here in Kansas City. On the Kansas side, HGA was the architect out of Minnesota. This is another angel hair stainless project. This is for a church. It's called Church of the Resurrection. So there's 7 of these sails that go around the building, and each one's clad in angel hair stainless. This is a unique one where we applied 2 finishes to the same sheet. What we did with this one, this is the 9/11 memorial in Manhattan, and what we did on this was we brought the material in with the number 4 finish. That's the more reflective surface that you're seeing there. We masked off those areas and then put it through our glass bead machine to give these matte stripes on the surface. So this is a unique one where we took one sheet and applied 2 different surfaces, which takes some testing because there's a lot of things that can happen when you're applying finishes, 2 different finishes to a surface, because when you're removing, like the glass bead is applying to the surface of this material, it's actually removing some of the material, or it's moving it around. So when that happens, the sheets can bow. You can get a lot of warpage in the material, and so then flatness criteria can become an issue. And so that's something that we have to take into consideration when we're developing a finish like this. This is the Performing and Arts Center here in Kansas City. This is the glass bead surface. So Moshe Safdie is the architect for this project. These ribbons on the back side are all, like I said, the glass bead stainless steel. And then on the base of the building is are these concave roof areas that also have the stainless steel. This is a Zaha Hadid project that we worked on at Michigan State. This is the angel hair stainless steel. So the unique thing about this project is you can see where these ribs are tapering, and then at some point they dive back down into the surface where you're seeing these triangles. So when we were fabricating these here in the shop, we would break form as much as we could. And then there's going to be that one opening that you have to weld shut. And so we would break form these and then weld an area shut and then apply the angel hair finish over the weld. And if we ever have a chance to go see that project, I would challenge anybody to tell me which of those is welded and which of them is not. It looks really nice. More stainless steel projects. I think I'm going to run out of time here earlier than I thought I would, so I'm going to go through these somewhat quickly. So this is a project in Seoul, Korea. So we took mirror stainless and we applied the bump forms, but we also did the perforation. So we put the perforations first and then did the bumps, and kind of gave this googly-eyed effect on the surface. Then we've got more angel hair stainless. So this is Kauffman Stadium here in Kansas City. We utilized our image wall process to perforate. So these are a more open space perforation areas, and then where the letters are, there's not as much perforation. So that's what's creating the text on the surface. Now we're getting into the colored stainless. So this is what we call interference coated stainless. So this is a chemical process where the stainless is dipped into a solution, and it actually increases the thickness of the chromium oxide layer on the surface of the stainless, and then how light reflects off of that chromium oxide layer gives you the different colors. So this is a gold stainless steel, and utilizing that process, the color's never going to fade. It's not like a paint, it's not a coating. 50 years from now, this will still shine the day that it, just the same as the days that it was installed. More colored stainless. This is the Museum of Contemporary Art in Cleveland. That's a black mirror stainless. This is the Neiman Marcus store in Natick, Massachusetts. This is Elkis Manfredi. So they utilized 3 different colors of bronze stainless to kind of give it this striping effect. Here's another one with exposed fasteners on the skins. This is a parking garage in Miami, Florida. This is with a gold-colored stainless. This was, again, I've mentioned the design assist process. I'm going to get more into that now. So this is utilizing our design assist process, where we get in early with the design team and come up with the best options to meet the owner's budget. So the architect comes to us and they have an idea of what they want to see. So then we start, talking to a contractor or the architecture firm or the owner or whoever is appropriate for us to talk to at the time, and start discussing what budget is going to be allowed for our portion of the work. Sometimes that budget's too low, and we quite honestly don't get involved. Sometimes the budget's challenging, and in those situations, then we start talking with the design team to figure out a way to achieve what they're looking for that budget. Very rarely is the budget too much. So here you're seeing the backside of that facade. You're seeing the vertical mullion there with the stainless steel panels. What we call our drop-lock system. So those vertical mullions have slots milled into them, and then the panels have tabs that engage into the slots. On this project, so this is the same project we were just looking at. We would water jet cut these cuts here, and then fold those blocks out. And so you're seeing this nice texture going across the facade. And what ended up happening on this project is this design is by Leon out of New York City. They brought us in because they had some ideas of how they wanted to do their facade. As we got talking to more of the team members of this project, we discovered that there were 2 more facades for the same parking garage. The one opposite Leon is an Iwamoto Scott design using painted aluminum, and then in the middle they wanted to replicate an image that was chosen by John Baldessari out of San Diego, and they wanted to apply that to the surface. So we utilized our image wall method of perforating to achieve this image. So these are the visual mock-ups. So this is in Kansas City. We were meeting with the design team early on. We did the actual framing, assembly, and everything, put it up on our mock-up towers so that the architect could see and buy off on exactly what we were planning to build. So this is Leon, this is the Baldessari facade, this is the facade. This is another design assist project, it's a parking garage in San Francisco. We were challenged here. They came to us with a budget that was very challenging. And WRNS is the architect on this project. They had a design in mind, and we were able to work with them to utilize the exact same shape, the exact same color of extrusion for every one of these pieces, and make an easy way to apply it to the surface. So what you're seeing here is, you're seeing lots of different colors here, but all of those fins are the exact same color. You're just seeing the light reflect off of it. It's another Morphosis project, another design assist where we were brought in early. This is the mock-up that we produced for that project. And this actually, so this is on some college dorm rooms. You can see the guardrail behind the systems are incorporated into our scrim wall. So it's similar to the parking garages where we're using the vertical mullion as the framing system, and we're applying these different shapes to the surface in the pattern that was defined by Morphosis on the project. And then the cable system for the guardrail was incorporated into our system for the guardrail. So as far as contractual relationships throughout a project, I've talked a lot about design assist. This is the area we try to stay in. A lot of times we get pulled into these publicly bid, design bid build traditional methods of project delivery, and those are just problematic for us. They're high effort, so it takes a lot of time to come up with pricing and proposal and sending a proposal out to all of the different general contractors and working with, I just saw two working with installers and such to try to bring in a project, and then what ultimately ends up happening is somebody comes in and doesn't understand what they're bidding and ends up being half of our price because either they don't understand it or they made a mistake or whatever. So it's not a good situation for us to be in that area. We try to stay in this design assist method. Installation-wise, we do a lot of installations in the United States. But as you can see here, we've done projects all over the world. Naturally, we don't do installations in some areas. We've talked quite a bit about the customization and our methods of using the image wall. So we do have some software on our website if you want to check that out. We have image wall software that you can pull up and put your own image in there. We've come up with some different methods to automate some different ways of using perforations, having somewhat of what I call hanging chads in the perforations and moving those in different ways to achieve different textures on the surface. So there's a lot of different ways that we customize things, but the key to getting that customization into your project is being able to perform a design assist and getting us in early so that we can help with those ideas and help with the methods to achieve the different projects that you're wanting to see. So I've got some more things here that I could talk about, but I'll open it up for questions from that.
Thank you, Eric. Appreciate it. And as you guys know, this is, you're okay. I just looked up your title and didn't realize you were the director of estimating. So if you have cost questions, this is the guy to go to. It really is cool that they do so many things all over the world, such innovative things kind of in our backyard. So I encourage you. I don't know how it works if you want a tour, but if you're in the Kansas City area, I'll just give them your name to start. It's Eric and Steele with an E on the end. But we could organize something if somebody wanted to see it. I haven't been there since they've renovated, and even before then it was pretty impressive. Does anybody have any questions? We're all good? Okay. Well, we've milked the hour, and I think go-to meeting is going to kick us off any minute anyway. So, Eric, I appreciate your time. If you guys are interested in more samples or anything like that, I'm sure they would be happy to help you out. So, thank you very much.
Absolutely.
Have a good
All
rest.
right, thank you.
Thank you. all the fruits.
What?